Good morning. Welcome to another episode of XR Talk Show. Today is June 20th, 2019. We haven't had this for a while. I've been skipping for the past 2 or 3 days, but we are back. And today we are going to do this. Let me show you what we're gonna do. We're gonna talk about the ellipse issue. We're gonna talk about JavaScript, SVG, coding, drawing a ellipse, a circular arc. That's one thing we're going to talk about. And we are also going to talk about the use of math symbols in programming languages, function names. So let me get you to what we're going to show. So Kasali JavaScript blog, okay? We go to Saudi JavaScript blog, and you can see that's my web dev blog. And there's a bunch of things. This we did. I finally coded this, completed, and this is great. So you go there. So that's what we're gonna talk about. This thing, okay? So this thing, let me show you the other thing we're gonna talk about. So the other thing is Xali blog, okay, programming blog. We go to the programming blog, and there it is. You go there, and a bunch of very interesting, highly interesting Unicode stuff. Unicode and symbols and syntax and and writing systems. That's all related to these symbols. So the other topic we are going to talk about is the use of math symbols in programming language function names. I have some examples here. Let me show you. Google Ads every page on every page. Google Ads. Well, anyway. That's another topic. We're gonna talk about that some other day. They anyway. So math symbol as function names in Python, Java, JavaScript, Java, Haskell, Perl, Python, Java, Golang, all these languages. So these are the two topics we're going to talk about. Let's begin with this circle arc. So if you are watching, say hi. Let me pop out this. Yeah. So if you're watching, say hi. So this. But before we do that, actually, I need to let me talk about. Let me type what we're gonna do. JavaScript SVG drawing ellipse arc and math symbols in programming in function names. Python Haskell act. Oh, it's full. Okay, that's the topic we're gonna talk about. So let's begin with the JavaScript. Let me show you this demo first. I finally did this. You see, so this is interactive application. You can adjust the center, then you can adjust the major axis or the minor axis. Then you can adjust at what angle you want to begin, and how much sweep you want. For example, let's say that, and we can do that. You see. Then this is rotation, how much the whole thing is rotated, you see. So finally I did this. I'm very happy with it. And there are several interesting things to talk about. There are several aspects we can talk about. Again, if you are watching, say hi. That would make the topic, the talk much more interesting, when you give me feedback. Any opinions or anything, feel free to type it. So this JavaScript. So we can talk about, I can give you a tutorial, a short tutorial on SVG. SVG is the scalable vector graphics. It's used to draw clocks or anything line oriented. For stock tick, graph, math plots, plotting mathematics, curves, functions curves. Um, uh, SVG is suitable. Your bar chart, pie chart, things like that. So SVG is the technology. So I can give you a short tutorial on SVG. And also I can give you a short tutorial on JavaScript and how to script the DOM, such as how is this program is written. Let's look at, so that's one aspect I can talk about, tutorial. The other thing very interesting about this thing is that the SVG spec, okay, that is the origin why I started to write this application. The SVG spec is one of the worst spec possible. Okay, so let's go to SVG. Let's go to my local website so it's faster to load. Well, except I don't have JavaScript on in Firefox, so why not? Let's just okay. Let's go to SVG. So you see SVG technology. The spec, it's got the sometimes when if you are a programmer, sometimes you programming some technology or programming language, you have bugs, right? You run into bugs or no documentation. It's very frustrating. You spend hours or days to find a bug, and eventually the bug is caused not by you but by because some idiocy of the programming language or protocol or whatever. So and such example are huge tons of example of these kind of thing in JavaScript and DOM technology. It's very frustrating. The browser doesn't support it, doesn't follow the spec, or the spec is simply stupid. As a programmer, you are probably very familiar with this. Good morning, Danielle. We haven't had a talk show for a while. How are you? So SVG, so sometimes you got lots of problems in technology, and there is one example in SVG that's egregious. Okay, egregious. What is the problem? The problem is when you want to draw a circle, you can do like this. Okay, it's very simple. That's all you do. You put this in a file and show in browser, and it draws a circle. And if you want to draw an ellipse, you can do as well. All you have to say is that ellipse, then attribute cx cy equals to then rx ry, which is the major axis and the minor axis. So it's very simple to draw a circle and ellipse. However, if you want to draw a pie chart, you need an arc of a circle. You cannot do that. It is possible, but it's extremely difficult. It is extremely difficult. That is why I finally wrote this app to do that. This is the app that allows you to draw. For example, let's make it 100 here. And make it, like if you want to draw a quarter of a circle, it's very difficult. Okay, so this is a major problem. Why does this happen? I'm going to describe the problem in detail, but why does this happen? Because SVG, when I was younger, I thought all these standards, they are created by all the experts, of a particular field. For example, we have internet, HTTP, TCP/IP, things like that. So that's internet protocol and email protocol and chat protocol. That's how the internet works. We got all these things works. On the surface, it appears it just works wireless. wireless and everything, but beneath its extreme complexity. Anyway, when I was younger, I thought, all these protocols and standards and language design, Python, Ruby, whatever, Haskell, they must be designed by expert, like maybe a group of expert committee, they gather together and talk, how to solve the problem for the world, and they eventually they design a thing that is the standard, or protocol. But as now I know, as you grow older, that's not like that at all. So how did this standard specification came around? Mostly it's social issues. Okay, it's nothing like you might think experts get together and design the thing. It's not like that. Rather, it's mostly okay. The major reason the standard form, how they form, is because one, the most important critical reason is that corporations, greedy, uh, money oriented corporations, they want to make something, they want to make money, they want to sell it, they want to, maybe they created a language, new technology or whatever. For example, Microsoft, everyone hates Microsoft. If you are my followers, you probably hate Microsoft. For example, Apple. Apple is very well known for it. Apple, everything is patent and greed, and they, although they usually do extremely good design, but still they want to make money. Money is the main thing that drives Apple, as well as Microsoft. And today we have Google. Google is a company that was supposedly do no evil, and today it's the most evil possible and the most powerful and evil company. They do, their browser, Chrome browser, before it's like, oh, let's follow standard, but now they intentionally do devious things so that nothing runs in other browser. They only run in Google Chrome browser. um, so how did the standard came from? So usually the one most major reason is that the corporations, money hungry corporations, they created, they publish it, and in hope that all the people will use it as a standard. Like now, this is our standard. For example, Apple has Swift programming language, Microsoft has the Direct 3D. What's it called? Direct 3D. Yeah, for computer graphics games. And tons of things. File systems, NTFS file systems. Apple has their proprietary file systems. Um, and if they publish it as a standard, often the reason is that they want you to use it, but meanwhile, eventually they charge you like annual developer fee. For Apple is like $100 or something. Microsoft the same. And so many examples. JavaScript, for example, where does JavaScript uh, uh, spec came from? Could I make a pie without pie? Okay, so where does JavaScript spec came from? It came from because Netscape created this language. They want to sell it, and you know, and back then, this is 1995 when open source is becoming, coming on the scene. So then Netscape want to make a standard so that, anyway, and I mean, we are not going to talk about JavaScript history because I talked about that for several times, and also, as you know, Java, also money hungry. Java is like, at one time it's, oh, this is open source. At one time it's, this is a trap. Richard Stallman says Java is a trap. Now then, after some Microsoft eventually released it as like some sort of true open source, then Richard Stallman says, "Oh, Java is now," he endorsed it. Now then, Microsoft got sold to Oracle. Why? Because money. Otherwise, you wouldn't be sold. You sell when you are failed. When you failed, but yet you still, of course, there's still money to get by selling your company. So they sold to Oracle. And then Oracle, Oracle is another big money greedy company. So they did something, then they screwed up, so now it's like JavaScript is no longer open source. It's like borderline, like it becomes no longer, doesn't, depending on who you ask. Then there is Google, of course, greedy Google. They developed their Android phone based on JavaScript, Android OS. Why? Because well, that's history. That's, well, because originally, because the Google founders, he know Java the language. That's how he learned at Stanford University. So Java, and then Google started to use Java for Android, and that's how Java becomes popular. Java was about to die. Google saved it twice. The first time is around 2001 when Google decided, they are going to use Java for their corporation coding. Java is their main language. Then around 2000, let's say 2008, or when Android came up, Google decided, we're gonna Java the language is the language for the Android operating system. So Google actually saved Java twice. That's why Java is still today the most popular language. By the way, Google also made Python popular twice. The first time is 2010 when Google decided, Java is their main language, while Python is their main scripting language. Back then, the other choice is Perl. You don't have much choices. Then around 2010, let's say, or 2011, Google again made Python popular by they decided because AI became popular, the data mining, the AI, the um, artificial intelligence. So Google decided they are going to, Python is their main language for interfacing with, machine learning stuff. By the way, the real machine learning code is typically written in C or C++. I'm pretty sure. I think, yeah, not in Python. Python is usually almost used just as an interface. So anyway, I digressed a lot. So we were talking about how these standards or languages specs they came to be. So I was saying, the major drive is corporations and money, greed, fighting. There's a lot, serious infighting, like lawsuit, $1 million lawsuit. If you did something I don't like, I'm Apple, for example. If Microsoft, you did something I don't like, I sue you for $1 million because this is critical. Money is talking. And Microsoft did something, then Linux tried to do something Microsoft doesn't look like, they sue. Similarly, for some microsystems, Oracle, Google, Apple, this is kind of like common, typical happenings. So because of these, that's how programming languages get created, and programming technology get created because of these. Now of course there are a lot academics, they also create some design languages. For example, scheme Lisp, for example, the racket today is known as racket, and many others. But typically they don't survive. Okay, they don't survive. It is the big, giant, greedy corporations. Their things survive for many reasons. One of the reasons is because the corpse has money. Greed is based on it. They make money. Everyone has greed. Everyone needs to survive. Like money is a drive food is a drive, the comfort, living is a drive for everyone. So sometimes you got these academics, they design things, but usually they don't sell. They don't become popular. They die out because for many social reasons. One, because you know these billion dollar corporations, they have far more resources to market their thing than your little one guy's thing. That's one reason. The other reason is that these academic things typically, at least in America, they are like um, they are began by these open source kind, supposedly kind people. They are not greedy, okay, and in some cases, they like open source or free software, so they are based on communism ideology. So what is the end result? No, nobody gives a shit. People just use your stuff for free. Free software, free means everyone can download it. No pay. That's what it means practically. So you don't grow, like Emacs, Emac list, you don't have support, nobody cares about you, but you based on the ideology of moral, some kind of moral, ethical. Oh, we are ethical, so you trying to survive or spread your software based on that, and the reality is nobody gives a fuck. So typically the academics stuff, they don't survive. I don't mean just that they don't survive because you may not know, because right now, or everything like let's say there are 100 things about programming, 100 items, languages, protocols, whatever. Suppose 100 of them. Chances are 98 of them is all from corporations, maybe two are from academia. Okay, why? But actually, in fact, there are a lot from academia, but they all died out because you never heard of. That's the thing I want to say. You never heard about them because they don't because that's the thing about popularity. You don't know their existence, unless you like take the time to research history, or what happens. So anyway, I digress a lot. So back to, what we were talking about, the spec, how they got written, how they become standard. So DOM, SVG. So how they became standard? Okay. And the other thing, so why are we talking about SVG? I mean, what's the problem with the ellipse, drawing ellipse? Uh, Let me show you. Okay, but first of all, what I want to say is that it's just extremely bad. Like when you code DOM and web stuff online, it just you know sometimes you look at the spec, what the fuck are they doing this, it's strange, all that. Anyway, okay, that's digression. That's about that. Now let's talk about the SVG. Why does it? What is the problem actually? Okay, so let me read the questions. Daniel says people that know trigonometry are probably going nuts right now because they are highly strong crowd. So okay, so is that a word play on the strong, like a string? Like you using strings going around, like measuring stuff. So anyway, let's talk about, I think I rambled quite a bit today, so 23 minutes. Let's talk about the um, let me discuss why JavaScript um, SVG sucks. I mean, let me discuss what is the problem with the SVG. Okay, so you want to draw an arc of a circle. Let's say a quarter of an arc of a circle. Okay, you want to draw a quarter of an arc of a circle, kind of like that. Okay, so we have kind of like that, and you cannot do that. You cannot say circle center, then radius, then how much you want to draw. No, you have to do what you have to do is you have to use these path elements. Let me show you. Okay, SVG path element. Now path element you can see is this. You say path, then you give it a bunch of D, M, L, like M followed by two numbers, L followed by two numbers. Then there are other commands, M, L, there's A, there's others. But anyway, so this syntax is rather fairly complicated. Okay, let me explain. So M like mountain, M followed by two numbers. That means move the pen to those two numbers coordinate. Then L means draw a line to that point, from the previous point. So M is move the pen to, L is draw a line to. Okay, so that is the syntax of the path element, which is fairly complex. Then, so besides M and L, this M followed by two numbers and L followed by two numbers, those are called commands. Technically the jargon for to describe those are called commands. The path is a element, HTML element. So then you have the D attribute, D for draw, I guess. So the path element has a D attribute. Then the value of the D attribute is a string. Then you have this M number, L number stuff. That's how you create a path. Now the path element is very complex because you can actually draw curves like elliptical arcs or quadratic Bezier curves or cubic splines, cubic Bezier curves. It gets very complicated. But however, they are all using the path elements. Path D equals to then a string. We have M, L, we have Q, we have A, we have H. Very complicated. But back to the topic. How do you draw an ellipse? So the way you draw an ellipse is by using the path element. For example, we are drawing half a ellipse here. So what you do is this. So there is one of the command is A followed by 1, 2, 3, 4, 5, 6, 7. 7 numbers. That's how you specify a ellipse inside the path element. So it's fairly complicated. Good morning, Shui Yang Liu. I thought it's a Emacs show. Yeah, normally we talk about Emacs, but today we're gonna, today's topic is the JavaScript and math symbols. So, if you have a Emacs question, you can post it. Okay, I maybe I'll answer it at the end. But otherwise, I'll talk about it. Next day's topic. So anyway, so to draw a ellipse, you have to use the path element, and it's very complicated. You have to type capital A followed by 7 numbers. Now, what are the 7 numbers? They are Rx, Ry. Those are major and minor axes. Okay. Then rotate is the number, how much you want to rotate the ellipse. Then large arc flag and sweep flag. Those are either 1 or 2. Very complex. Then the last 2 numbers is XY, where the ellipse ends. So I'm not going to explain these 7 numbers, what they mean, but you can understand. It's very you can understand. You can see that they are not the typical the ellipse you understand. So you have this. I'm not going to explain. You can check out my website here and read about it. I explain in detail. So here is also a interactive thing you can show. You see, it's very very complex. It's so our goal, what I want to do, and this is very common. Okay, you want to draw a quarter of a circle. So So how do you do that? It turns out it's just it take you hours and days to figure it out. You cannot you cannot draw an arc of a circle like a pie chart. You cannot draw it. So that is the problem. So I spent days, to try to find out, and eventually that's how I wrote this application. You can see finally I succeeded. I understand the full thing and I know how to draw it. And by the way, this is just a path element, just like the trick is figuring out what numbers it should be. You see, the way these seven numbers works is that they are based on, let me tell you what they are. They are based on, um, it's complicated. Let me show you what normally ellipse means. Okay. So normally we have a ellipse like this. Okay. Let's say like that. And normally, an ellipse in a standard position like x-axis, y-axis, you have this shape, and from here to here, it's called the major axis. Okay, the horizontal axis, the x-axis is the length from here to here is the major axis, and from up and down is the minor axis. So you can, for example, you can adjust. You can get a circle. You can, for example, then you can get different shapes of ellipse. When the major axis and minor axis are equal in size, then you get a circle. So to specify a ellipse, normally all you have to do is you specify a center, you specify the major axis, the length, and minor axis. Then you specify which angle you want to begin to draw it. At what point you want to begin to draw it. Then how much of a sweep you want. Okay. Then finally you say you rotate the whole thing. You want to say how much rotation you want the whole thing. So you have how many parameters? 1, 2, 3, 4, 5, 6, 7. 7 parameters. This is a intuitive way to understand ellipse, to specify ellipse. In fact, this is the standard way to describe an ellipse in mathematics. When you do algebra, when you do analytic geometry, which is pre-calculus, or when you learn calculus, you study, you understand this. But in the SVG spec, remember it's a path followed by 7 numbers. These 7 numbers are nothing like what we had. These 7 numbers, okay, the way they specify it is that they specify ellipse by a starting point, the point does ellipse begin, and the end point. Then you specify major and minor axis. Then you specify rotate, which is the final rotation. Then you specify these 2 Boolean numbers. Like it's very difficult to explain actually. So you can see here, this is how they specify ellipse. So normally we specify ellipse by giving a center. Once you have a center, everything is easy to understand. But in the SVG way, you don't have a center. You have start end, then you have this arc. You have to give a Boolean, large arc flag, sweep flag, to determine which part it is. And I've never, I studied math. I'm a math fan for 20 years. I never seen this thing. But then when you go to the SVG spec, let me show you. I talked about this before. They like this is SVG version 1 spec. You can go to SVG version 2 spec. SVG spec. Right now it's version 2. Version 1.1 is like from 2001 or so. But anyway, SVG version 2 is not popular yet, meaning that most browsers do not implement it. So let's go. So we go to SVG spec version 2, and you can see. Let's go to ellipse. These specs are. So you go to the path element. You go to the path element, and one of the command in path element is the elliptical arc. So you can see, you can read, here it's extremely complicated parameters. Nobody understand it. You can spend. I challenge you. Try to. Hey, hi, goodbye, Danielle. I challenge you to code this ellipse. Try to draw a quarter arc of a circle. But anyway, so they have a implementation note here. They here they explain how do you convert ellipse from the center based parameterization to the way SVG defines it. It's all crap. They don't believe what they say here. Like they have a article here. They have a article here somewhere, like notes. They tell you, like they try to define, they try to explain. For example, they have a notes here, annotation. SVG2 requirement make it simpler to draw an arc. Draw arcs in SVG path syntax. You see, they have these notes because it's a problem. A pie chart is very common, but few people can understand it. So they have a note here, but however, it's not. They just have a note to themselves. It's not anywhere in the spec. You still cannot do it. There's no easy way. Except you write a function to translate the parameters. So they say, so the SVG spec says have note. This is so it's stupid. But also somewhere they say that somewhere they say that the reason they did it that way is because it's more consistent with their path syntax. I don't think that's a valid reason. I think lots of these documentation, when you read specifications, standard specifications, lots of it is crap. It's garbage. The writing style, just almost about everything is garbage. And actually, the SVG2 standard came from written by one of the author, which is a woman who described her. Let me show you which who it is. Editors: Amelia Bellamy Rhodes. Okay, supposedly she's an invited expert as a credit on the SVG spec. So she wrote a blog that details how she got into the SVG, how she became involved. And if you read it, it's kind of a sad story. It basically is like SVG. The way SVG2 is created is not anything about, it's not like anything that makes sense. It's like nobody cares about SVG. No browser implemented. Like nobody. Then they try to do it, from these contributors, like typically not paid, then they just create it out of blue. Like they don't have expertise. For example, Amelia, she's not a mathematician. She's not experienced in I'm not sure she even has graphics programming experience. But anyway, she's good because she studied. If you read blog, she's good. She learned study the full details of SVG. So she became an expert. And she got invited, and they just try to do things like out of blue. So it's nothing like one would think that it's these standards are created by experts. So this is my opinion that most of these specs are just crap, garbage. Okay, so that's about, let's see, 6 people watching. Good. So any comments, opinions, post it. Okay, the more opinions and comments, the better I can, I talk to the about the topic. But anyway, so we have just explained. I suppose we have a basic tutorial of SVG. We explained the path element. We explained why it is so difficult to create a pie chart in SVG, and I also gave my opinion about how standard spec are typically just pure crap. They are nothing. Don't like these standards. Like typically programmers, especially the Linux elite people, they always say, "Oh, follow standard, follow standard." The standard, usually is just crap. It's not good. And also standards, although they are not corporations, the standards bodies such as W3, they are typically backed by money. Like typically they are non-profit organizations, but they are driven by profit. That's usually the case. So clearly Clever says, just got here, no opinions yet. Great. Okay, great. So that's about the topic about this SVG and Ellipse. Yeah, that concludes this topic. Now let's go to the next topic, which is the fun part, kind of. So math symbols as function names in Python, JavaScript, Java. Okay, let me show you that code for the Ellipse. So let's go to my JavaScript blog. Let's go to the Ellipse arc. So this is the page. It has JavaScript turned off, but let's look at the JavaScript code. So here is the JavaScript code. Let's magnify, and you can see. So you define this is the JavaScript code. I'm showing you just for fun. This will lead up to the use of math symbols in code, such as that, delta, phi, and we have delta, phi, and theta and stuff. Pi, you can see pi here. Okay, so this is JavaScript. These are convenient. You define cosine equals to math dot cosine. It saves typing. And now you can define pi, by the Greek letter pi, for math dot pi. So that's very convenient. Then you define the matrix. This is the matrix function to multiply a vector, which is essential when you do any kind of computer graphics. Computer graphics. So you need to. So you have a matrix function, then you have a rotation matrix, then you have vector addition. Vector A B C D equals to A plus C plus B plus D. Things like that. Vector addition. Then you define the ellipse function here. So anyway, I'm showing this just to show the code for fun. So it's about 100 lines of code. So that's that. And then we are back to the math symbol as function names in Python, Java, JavaScript, and Haskell, and Emacs, Lisp, and other languages. Okay, so So this is interesting because if you look at the ellipse code, for this code, you can see we have used the symbol. This symbol is convenient because actually it matters because then when you have lots of math expressions, uh, symbol condenses the whole thing. For example, if the whole vector add can be just one symbol, let's say if I replace it by, let me show you. So vector add is a function. Now let's just replace it by a symbol. Let's say circle plus. Okay, replace, replace, replace. You see, now it's simpler. Now if the matrix times, we also replace by a single symbol. Let's say circle times. Okay, so that makes the thing much simpler. And similar, we can do that for that, because when you read math, you see you see a bunch of symbols. If you try to expand those two words, it's gonna be unreadable. So anyway, so that is why it is important for languages to support symbols as variable names. So we have a pi here. So we look at, so we want to be able to use pi or alpha, gamma, beta, theta for variable names. Very convenient, especially when you do sine, cosine trigonometry, linear algebra for computer graphics. You need lots of angles. Angles are usually represented by sine, cosine, by alpha, beta, theta, Greek letters. Um, when you see a Greek letter, it's radian. It should be an angle, not a degree, for example. So that's convenient. The other thing convenient is that you want to be able to use a symbol as part of the function name. Then the other thing is that you want to be use an operator, meaning that, for example, vector add, for example, let's say magnify. So vector add, instead of a vector add, for example, we are going to vector add two vectors. 1, 2, okay, 3, 4. This should give us, this should return 1 plus 3 is 4, 2 plus 1, 3, 2 plus 1 plus 3 is 4, 2 plus 4 is 6. This should give us 4 and 6. So instead of writing like that, we could use, if we could use just that, this is much simpler, or some even that. Let's remove the. Okay, for example, instead of that, if we can write that, is simpler. Even better is that if we can define an operator, so the whole thing will be written like that. Like this. Symbol with Unicode. Name with math symbol. Okay, normal. Okay, so this is, so name with math symbol, that's good. The best is to define, to be able, the programming language allows you to define operators, and if it can use Unicode's math symbols, that's the best. So that's what we want. So I surveyed different languages. You look at C, Golang, Java, JavaScript, Python, Perl, Ruby, OCaml, Haskell, Emacs, Lisp, Julia, Mathematica. So here is the result. So let me tell you what's going on. Typically, summarize. Let me summarize. What's going on. First of all, C is the worst. C supports none of these, except if you do, if you use special compilers or special extensions. The standard C, or the classic C, does not support any of these. Now, in most other languages, for example, Golang, Java, JavaScript, Python, and Perl, you can have Unicode as a variable or function name. So you can have these. However, there is an exception. For example, you can have alpha. Okay, there's a one issue. You can use a Unicode character, except one condition is that Unicode character must be a letter. Unicode, each character has a property. Some characters are considered a letter. For example, alpha, beta. Greek letters. Uh, let's look at. Most of these languages, Chinese characters, Japanese characters, Korean characters, Arabic, Ethiopic, Indian, Bengali, or whatever, those characters are considered letters. Okay, those are letter characters. I mean, each Unicode character has a property, so all these are considered letters. However, some other characters, such as you know, dingbats, stars, these are not letters. So you cannot use these symbols as a character in your variable or function name. You cannot use stars. You cannot use crosses. You cannot use, for example, emoji, because they are not letters. Uh, the most devastating is that you cannot use any of the math symbols as function names, as anywhere in your function or variable name, because these math symbols, they are not letters. They are not classified by Unicode as letters. They are classified as symbols. So all these operators, you cannot use. So that means you cannot use this. You cannot do this in most languages. So that is includes Go, Java, JavaScript, Python, Perl, Ruby. They all allow Unicode in names, but only letter characters. Then at the next level, you have Ruby, which allows math symbol in names, and you have Emacs, Lisp, Julia, and Mathematica. They all allow. Okay, so that's better. So in Mathematica or Ruby, this is allowed. This is allowed. Now let's go to the next step. The next step is, does the language allow you to define operators? Most languages no, except Python, and I don't know about Ruby. So anyway, Python, OCaml, Haskell, Julia, Mathematica allow you to define your own operators. So that means they can, you can define, for example, you can do this, define your own operators using ASCII charts. For example, hold on, should be here. For example, let's say plus plus. Okay, or you can say v plus. Okay, so v plus stand for vector plus vector addition. So you can define these. So Ruby, so Python can do that, or Camel can do that, Haskell can do that. You can define your own operators. This is better. But however, there's another condition, that is, do they allow Unicode symbols as operators? That's the next level, and at that level, only Julia, as far as I know, Julia and Mathematica allows that. So that's about that. That's interesting about. So why you want this? Because when you are, most programmers are industrial programmers. When you go Hacker News or Reddit, the vast majority of things you see people talk about, they are industrial programming. They are, vast majority. Most people are. They are not math oriented or scientific programming. Industrial programming is, for example, game programming, games, networking protocols, internet programming, AI programming, machine learning, AI, whatever Google is doing, Facebook. They are all industrial programming, vast majority. Programming web browsers, programming applications, programming Linux kernel, operating system drivers, and web dev, and web server. They are all industrial programming. So, but they are not scientific programming. Scientific programming is the programming. For example, machine learning has a lot of scientific programming involved, and actually, gaming. The algorithms used in gaming, linear algebra, computer graphics. And many research in physics and academia, used by NASA, for example, NASA sending people to space, and the companies that sends rockets and stuff. Anyway, so the point is, when you do mathematical programming, this becomes rather critical, because let me show you some math stuff. Because then that'll be it for today. Because when you do math programming, let's see, syntax soup. Let's show you some math programming code. So you see, this is this is math code. This is creating a find the angle between vectors. So in Mathematica syntax, you can do it this way, like this. It's actually two-dimensional. But you can also write it this way. If you want it to be one-dimensional only, note that you can have pi here. Then you can also do it this way. This is the least readable. This is all purely nested brackets, and this is similar to Lisp. This code can be converted to Lisp. So in Lisp syntax, it looks like this. So when you have lots of, let me just show you an example. Let's say, 3 plus, let's say in traditional notation, 3 plus 4 times 5, raised to 6. Let's say how you do that in Lisp. It's a problem. So in Lisp, you're gonna do is you're gonna write plus 3 4, then times, times plus 3 4, then power, then power, plus 3 4 times 5, then power. So this is like that, 5 6. So we have here normal math notation. Then we have the Lisp notation. You can tell which one is easier to read. in math, let's say math, you can see lots of let me show you some typical math formula. Let's see. Let's go to images. Yeah. So we got a bunch of math formulas. You know, Now this very simple expression in Lisp it becomes that like that. How you gonna do? I mean, so let me show you another. It's unreadable already. This is unreadable. This simple expression in this syntax is unreadable. Let me show you another normal functional in programming languages. Okay. Then we have. So we're gonna write plus plus 3 4 times power 5 6. So this is how you write in normal programming languages. Now you might object, wait, plus is not like that, times is not like that. But we are making examples, because when you do math, for example, these expressions are not just plus and minus. For example, the numbers are not numbers. Those, when you get, for example, they may be vectors. For example, these 5 6 3 4, they are vectors. They are not numbers. So you cannot just write, plus 3 4 in programming languages. Like our JavaScript example when we try to write the ellipse function. So this is how it looks like in normal programming languages. It's not readable. If you simplify it, it might be looks like that. It's not readable. So you need the infix notation. But why do we need Unicode? Because when you are doing vectors, for example, these 3 4 5 6 are vectors. So you are not doing normal numbers. So you need you might want to have a special operators to you know so you can see, oh, this is multiplying vectors, or adding vectors, or complex numbers. Okay, that's it for today. That's the two topics we want to cover. That's it. So thank you for watching. Any questions and comments? Hi, Hokensu. Hoken Situ. Where you from, Hoken Situ? I see you got a Goland mascot as your profile. So that's it for today. I'm going to have I guess I'm going to get dinner. So today we talked about the drawing a ellipse in JavaScript and SVG technology. Then we talked about a short tutorial on how you actually do it, a short tutorial on SVG. Then we talked about the complexity of standards, how they form, where they came from, the standard organizations and standard body specifications. Then we talked about the use of math symbols as math symbol in function names in different programming languages. Why we want that? What is the issue? And a survey of which language supports what. Yeah, that's what we talked about today. And lastly, yeah, as part of the explanation, we explained why is it necessary when you do scientific programming. Why is it extremely convenient to be able to define operators and to be able to use math symbols. Okay, who can sue? Who can who who can choose? Says, hope you can do some Lisp tutorial in the future. Yeah, I can do Emacs Lisp. Yes, I did one a few months ago. I think you can find it if you search for. Have you seen that one? So if you go to my YouTube, you'll find a. I did one uh, tutorial about teaching Emacs Lisp, from the beginning. So I think I'll do another one. Yeah, I should do another one soon. Okay, that's it. Thank you guys for watching. So if you like my stuff, support me. Okay, go to Patreon. Put $5, a month, or buy my JavaScript tutorial. Yeah, my JavaScript tutorial is the JavaScript in depth. You can learn everything about it. JavaScript in depth. Yeah. Okay. Thank you guys. Have a good day. Bye.